And this time in the workshop is a vintage synthesizer. It was made in Italy. It's the ELKA Synthex. A rather expensive instrument we launched in 1981 and still worth a lot today. It's an 8-voice analogue synth, 61 keys and lots of knobs and buttons. This one is in beautiful condition. So it's got a sequencer. I guess you can program your own things into this. There's a low frequency oscillator. Now I know what one of those is, but quite what it does on here I'm not entirely sure. Probably does some sort of flanging effects or something. I do at least recognise some of these things. So I've got the same things on my test equipment. Now it's got 2 oscillators per voice, I've read that somewhere, which I think can be set to each one of these 10 programs. But then there's 4 banks as well, so I don't know if that means 4 banks times 10 programs. 40 different voices, maybe. And then there's more filters and stuff. I guess you learn about those by twiddling. This bit's more intuitive. Bit of pitch bending. And around the back there's still quite a few things, but my attention is drawn to the nameplate. According to Wikipedia, they made 1,850 of these things over a 4-year period. Now serial number 1492 must have been in the last year to my reckoning. This is quite a late one. The cassette interface, which I absolutely love the idea of, uses 3.5mm jack plugs there. Look at that. Got sockets for the sequencer. And then there's foot switch inputs, which I reckon are for live performances. It's got MIDI connectors on here. That shows it's a more recent one. Output sockets. At least I understand what they're for. And if you're in the market for one of these, maybe you can try these guys, FX Music Control, in All Sages, Staffordshire. However, I'm told it doesn't work very well. Let's power it up and see what it does. Or doesn't do. Now I quite like that. Sounds like test equipment. Just connect the outputs to my amplifier. Sounds a bit naff to me. Oh, what was that? Oh. What's going on there? Just on these other voices. Oh, the light's not working. That's not right at all. Might not know everything about these synthesizers, but I know a bum note when I hear it. These switches look a bit dodgy. They feel okay though. Weird. How about these? That's weird, you got 2 buttons out. It's like, yeah. 2 buttons missing from there. How about here? Are we seeing a pattern? Yes, that one will work. Yes, it does. These won't, and then these will work. Let's check this one again. That one works. Sort of. No. Yes. No. No. Yes. Looks to me like it's a bit of a keyboard matrix, and we've lost a couple of data lines by the look of it. I'll have to check them out. In order to make sense of it really, I'm going to map out every single button, whether it works or not. See if it makes sense against the schematics. This is by the schematic for the switch panel. Here you can see the push switches all along here. And each one of them is connected to a 74LS367. These are tri-state buffers, exactly what you need to write to a 6-bit data bus. Only there's a lot of switches to check. So oscillator 1, octave 1, 16, 8 no, 4 no. Well, that feels like it's stuck. Okay. 8 and 4 on that one. Funny when I press that, there's LEDs lighting up over here. Weird. This is more strangeness as well. So this one lights up properly. I'll press that one and that comes on. I'll press that one and it goes off. And that just blinks on. That tells me that the buttons are working. It's just not going where they should. I've noticed some of these, it's not the buttons aren't working, it's the LEDs. So I'm going to check the function. See, that one's not doing anything. That's right. So that one's working, it's just the LEDs wrong there. That's just the LED then. So to summarise, we've got a lot of faults all over the place. We've even got some LEDs that are all sort of joined together, all shorting on together. It's very strange. But all the switches and LEDs are all common to this data bus, this 6-line data bus, which goes all the way up here, all the way, and it goes into these chips here. These chips are both tri-state buffers. They actually are the same part number, apart from one's the other way around to the other. You can see the enable line on this one goes to W pan, which I think is write to the panel, and this one is R pan, which I'm guessing is read. So this one is responsible for reading the key presses, and this one is responsible for writing to the LEDs. So I guess I better open this thing up and take a look. It looks like there's only 4 screws to get inside here. My word, how long is this screw? Does it go all the way to the bottom of the case? No, just an inch. Needlessly. Oh my, that's a lot of stuff. Well, there's a power supply, that's easy to recognise. But what a stack of boards. What's there? 8 boards there? Wow. I guess that these boards here do the voices, because there appears to be 2 identical sets of adjustments on each one, and then there's 4 boards, so there's the 8 voices. This is bordering on PCB porn, this is, I have to say. I'm surprised to see so many logic chips in it, but it is quite old, this machine. And this stack must be assorted things, because they're all different, but I recognise some of this stuff. Here's a 6502 CPU, very popular at the time, used in lots of home computers. You can see this one's got a 4 MHz crystal. If that's clocked at 4 MHz, that's quite fast. These 3 chips with the labels on, these are EEPROMs, so this is to stop them getting erased by the light. These contain the read-only memory for the instructions for this CPU. I also spy a lithium battery. That'll be for storing the settings and whatever else is memorised in this thing. I'm surprised it's not leaked. This little board here I think is for the MIDI interface, based on that it's wired directly to it. It's interesting how you got the cable come from the CPU board, going straight over here to the keys. I suppose that makes sense, because that lets other instruments play this for you, or lets you play other instruments using this. But I am rather taken aback by all this stuff on the bottom of the control panel. Lots of pots, lots of boards, lots of wires. Now according to these drawings I'm looking for a board that's called CST5811. Now helpfully most of the boards actually have the same part number written on them. So this is 410 CST5801. Although you do have to read it upside down. And some of the boards have got it abbreviated, just the last bit, 803S, 802S. And here we've got 5818. So we've got 5812, 5813, and now it's 5814. But I don't see 5811 marked anywhere. Makes me think it might be this one. But according to the book, this is 5811. It's only got 4 chips on, and that one's over here. The only board with the right number of chips on is this one here, labelled 5810, and it's rectangular. That's something to note. That won't be the first time there's a mistake in a schematic, so I'm pretty convinced this is the one we need. But we can see the suspect chips there. It's one of these. In fact, we think it's this one. This will be IC7. I'm actually powering this off a variac, so I'll knock it off here. Just undo these little nuts. There's only on a few threads. Let's see which way this comes off. That way. That solves one mystery. It is 5810. Something I've just noticed that both of these chips have got modern date codes on. I think these are from 2009. It's not that recent obviously, but they've both been changed. Picked up one of these generic chip testers the other week and I'm quite impressed with it. Just turn it on. Let's put our chip in, although the handle's a little bit in the way. Now we have to tell it what the chip is somehow. So amplifier, transistor, Zener diode, other, light, 45 series, H, no. There we go, 74 series. And it's a 3. Oh. That way. 367. Tells me what I wanted to know. So that can go in the bin. That was so easy. I'm going to take the other one out. Let's see how this one goes. Faulty as well. Let's see what's in stock. Let's try these new ones in. There's one. Oh, is the beast of Bodmin again? Oh Alfie, you're a nightmare in here. Come on, get down. Down. Come on out. We don't want you ruining everything. Come on. Come on. I need to find some way to prop this up. Let's see if that works. Let's see if the faults have gone away. Oh, no. It's exactly the same. Well, so much that chip tester, I've suddenly gone off it. Let's put the old chips back in. See if there's some other options. Well, we thought LS because it's a low powered Schottky version, which it is. We'll try this HC version. Oh, now it's okay. And the other one? Yeah, also okay. Oh, I don't know. Just going to probe the LEDs with the scope, see if they're supposed to turn on. So this one works, it's been pulled low. And then it's been released, so it goes high because it's released. Okay. So what about the one that doesn't work? This is the LED number 2. There's our problem. So the LED is probably okay. I'm going to probe the data lines on this board. Data line 0. There we see a bit of data flashing up there. Okay. Line 1. And it's just sat high. Data line 2. Also just sat high. Okay, data line 3. There we see some data. Line 4. Yeah, busy. And data line 5. Okay, so there's something wrong with data lines 1 and 2. Okay. The problem is this data bus goes all over the front panel. And most of these panels have the data bus going to them. And you can see the brown and red wires on most of the boards. At least this board's only got the one wire on it, indicating that it's one of the ends. As does this board here. So I suggest it's teed off in 2 different directions on this board. So what I'm going to do is disconnect bits 1 and 2 off all of the other boards and see if the fault goes away. Should come off nicely. Old 80s solder. And finally this one. So what I've done is disconnected data bit 1 from all of these boards, which leaves it only connected to this one. And we've already changed these 2 chips, so one of these should be guilty. We'll just hook the scope probe on this one. Just put the power back on. Aha! Now we see data on bit 1. Just going to find out which board was causing it. Just turn it off again. Okay, let's connect this board back up. This is board 5817. Power it on again. And the data's still there. Okay, wasn't that one. Now for board 5819. And it's not that one either. Okay, next. This one's board 5818. Oh, look at that. That's the one. So I'm just going to reconnect all these now and check the fault stays away. Obviously I need to disconnect 5819 or I won't see the fault go away. But I'm going to need the scope probe back on it. Now that's working as it should. And you can see there's a lot more data because there's more things connected. Let's check the status of data bit 2, the red wire. Yep, still stuck high. And there's every chance the cause of that is on the same board. Just hang the probe off here. And there we go. Data bit 2 is restored. Well, I might as well reattach those because I know it's not the wires. So there's 3 chips on this board, 3 buffers and 3 flip-flops. Which one will it be? So the fault's something to do with these buttons here. Might as well unsolder these 2 chips here before I take the board off. Hopefully all the keys don't fall out or anything like that. No, that's nice. Well, I can pull these two chips out because they're already undone. Let's turn it on now. Let's check our data lines. No, it wasn't those two chips, so they can go back in. I'll get the legs to line up. Hang this back up here because it's just a lot easier to work on. Let's pop a random screw in. Solder these back up. And out these come. Needs a bit of help. Well, that'll be because I haven't unsoldered it at all. Missed one. Let's pop it back on. Let's see what that does for us. And there we have it. We have some data. So which one is it? So that one's okay. So it's probably this one. This is the 367. Let's check it also fails as a 748C367. No way. Absolutely no way. Wow. I'm going to put the flip-flop back in because it passed, but we'll see if we still got the fault. I'm not sure I trust that chip tester. In it goes. So let's power it in with the flip-flop back in. And it's working. There's data there. So we've got the new chips put in. Or new old chip. Let's try that now. And there we have it. Data. Let's check data line 2 as well. Yes, beautiful. So it was IC3 that was faulty, causing data lines 1 and 2 to be stuck high. I'll take the probe off before I try and shut the lid. I'd also better put these screws in, hadn't I? Let's try it now. It's an encouraging sign this light's on, it never was before, but we can go from all the way through here. Oh, we have got a dicky button though. There we go. It's mechanically a bit sticky, that one. Looks like it's working. Because I want to test the keyboard, I just want to simplify all the settings on here, turn this oscillator down. Actually, I'm going to put a scope probe on the output. Just hook it on there. Well, let's see where the bum notes are coming from. Looks to me like it coincides with this LED being on, which is this top board. Definitely trouble there. According to the service manual, that's this side of the board. But it is a rather long schematic, and it is reminiscent of the opening credits to Star Wars. However, that particular LED of dodginess is right here in the schematics, so we've only got to worry about this end. And what we can see here is an old digital to analog converter circuit. These two chips here, the LS193s, are binary counters, and they'll receive a clock pulse on this pin here and continually increment their outputs in a sort of binary coded fashion. Each one of these logic gates, these OR gates, have got resistors on the end, and each one's different. All the little pieces of current are added up together in this summing amplifier, providing a defined analog voltage. And you'll see there's actually two of these circuits, just the same. Only this one counts upwards, CPU means count up, and this one counts down, creating our different shaped tones. And that's what these buttons are controlling. So that's how the shape of the waveform is generated, but what controls the pitch? So this circuit here will cycle through 256 different voltage levels. So to change the pitch, you just change how quickly you cycle through it. And that's what this circuit does. This is actually another counter circuit. Creates a clock pulse for the waveform generator. So this pair of LS161 chips are 4-bit binary counters. And because we've got a pair, we've got 8 bits, so 256 different values. This one's actually clocked by input CP1, which is a 4 MHz clock, so it's pretty fast. So these chips are counting through from 0 to 255 at 4 million times a second. And how the tone is controlled is on these data lines here. So depending on which key is being pressed, some data is loaded in here, which is preloaded onto these chips, giving it a different starting position when it starts to count down at 4 million times a second. So that's probably where I need to start looking. So we should be using this wave shaper here, so I'm just going to pick up the outputs. Let's have a look at pin 2 on chip 3H, which is going to be this one here, next to these resistors. Let's find pin 2 on here. There we go. Definitely got trouble there. So I'm going to check that clock pulse on pin 4, chip 1I. 1, 2, 3, 4. There we've got the clock pulse. Oh. Yeah. We're closing in on this. So somewhere here lies trouble. First thing I want to do is check that this data bus is actually sending the right data all the time. And that's going to need a bit of specialist equipment. So we're going to break out the logic analyzer. Now this is going to take quite a bit of setting up. There's a lot of wires involved. So I'm going to connect this clip onto pin 9, which is like the clock for this chip. Oh, that sent it a bit wild. It doesn't like that. If I move it to the next chip along, has no effect to it. Still faulty, mind you. Just touching that chip. Doesn't like that. I may have found a problem already. I can take those off, at least for the moment. So I'll take this board off. Interesting to see all these chips are being replaced on this board underneath. This must have had trouble actually generating any noise at all. That's not the problem we've got here. Let's see if I can pull that chip out quickly. I don't have a clever shortcut for this part though. I'm going to change this chip as well, because this one actually provides that signal. Could have failed at that end too. Take one of these. And we want one of these. Sometimes new chips' legs are sort of splayed out a bit and don't fit, so I've got this little tool that squashes them in the right orientation. So I can put the 7442 in there, and same over here. Do you know, it's probably quicker just to press some keys and connect those probes again. We'll soon see if it's working. Oh, I didn't think it'd be that simple. Let's see what I can do with this. No, lower end. Okay, that works. Something more classic. That's how this sequencer works. I think I have to press right and then pick something and then ready. So to make it play, I think I'll just make it ready and hit a key. Well, that worked. Just turn it off again. I don't know the best way this is going to come off because it's got wires on two edges. Yeah, we will manage. So this button here doesn't feel much different. Probably just needs a bit of a clean. So it's rather a nice switch action, I have to say. And it mainly feels free, but it occasionally does feel a bit snaggy. To me, I can't tell if it's down here. This edge could be catching. It does seem a bit close. Well, it could be the actuator peg in the middle, which you can only just see. Let's see if it'll come apart. I mean, it must come apart because they assembled it. I'm thinking with these little hook parts here. So I can get a fingernail underneath. Persuade it to come up. Well, there we go. There's one side. Well, it's very nearly off, isn't it? There we go. And to be fair, nothing looks too dusty or dirty in there. I was expecting more, I'll be honest. May try a little bit of deoxit in there. It's mainly for its lubrication properties. See what it does. As soon as put this back on, you just push it. Ah, no. Engage the other end first. There we go. Okay, so we'll see how that goes. Works like a dream. And here's a familiar tone. Let's try this. Needs a little something. A bit of glide on there. I'm pretty sure that's fixed now, but I'm going to have a little play of it anyway. Catch you next time.